All right, so this is going to be examples 9 and 10. Examples 9 and 10 for 2.7. We're finally going to get the last part of it figured out. Okay, so for example 9, this is kind of where things kind of start getting interesting. They tell us all these words. There aren't really instructions other than the following words. It says, describe all values of x. Describe all values of x within a distance of 4 from the number 5. Describe all values of x within a distance of 4 from the number 5. Okay, so this should be ringing some bells here. You should be remembering we talked about distance. And when we talked about distance, we were talking about what kind of equations? Started with an A. Absolute value equations. So that's what it means here. It wants us to talk about the absolute value of a number, meaning the distance that the number is should be close as 4. The distance of 4, okay, from the number 5. So I want to be close enough to 5 that I'm only 4 away. What numbers might be like that? That they're at least or only 4 away at the very most. What numbers are that close to 5? 9. Any more than 9? 9 and 1. Okay. It says that they need to be within the distance of 4. So not just 9 and 1, but what else? Sure. So basically anything on a range from 1 to 9 is fair game. Any more than 9 and we're too far away, right? So how did you figure that out? You just mathed it? Subtracted what?
4 from 5. No one.
So you have 5 and you say, hey, my absolute value from the number 5 needs to be 4, right? But it doesn't matter if I'm 4 above 5 or if I'm 4 below 5. I just need to be able to say that the absolute value is less than or equal to 4. Would you agree with that? The absolute value of my number. So the absolute value of some number needs to be less than or equal to 4. And I'm trying to be a number around 5. So this is how we write that. Describe all values of x within a distance of 4 from the number 5. So we set the distance equal to 4. This word within translates to less than or equal to, in this range only. And we find that number by taking 5 away from it. Okay? That would indicate that my number was only positive 9 if I didn't show the absolute value. The absolute value allows it to be 1, which is 4 under, right? Or 4 below 5. So how do I solve this inequality? The same way that we solved all the inequalities, but we just add to the fact that it's an absolute value situation. So we consider both the positive side, which would say x minus 5 has got to be less than or equal to 4. So what happens there? Add 5 to both sides. X must be less than or equal to 9. No surprise there. We thought it was going to be 9. And what else? How might I evaluate this other side? The negative side. X minus 5 is what to 4? I got to have it negative. So now I'm saying my negative x minus 5 has got to be less than or equal to positive 4. Or I could say x minus 5 has got to be greater than or equal to negative 4. Good. Good. I don't just get to willy-nilly go make that 4 negative like we did before. Because it's an absolute value, I have to consider the negative, right? But because it's an inequality, when I make the 4 negative, I've got to switch the symbol. Got to turn that dude around. So now we can carry on. Negative 4 and 5 make 1. No surprise. We thought x had to be between 1 and 9. And on the number line, you would see that. You would see that x goes from 1 to 9, and it includes both numbers, and x is going to be everything in between. Those are all of the numbers that are within 4 away from 5. If we had to put that in interval notation, we would show that x can go from 1 to 9 and touch at both sides. So the main thing to catch right there, I want to bring your attention one more time. When you make this side negative, you need to switch your side. Okay. Everybody okay? All right, let's do one last example here. It's going to be example 10. Describe all the numbers within a distance of 3 from the number 2. Describe all the numbers within a distance of 3 from the number 2. So I want you to tell me how this equation or inequality is going to look. What's the distance? 3. Within a distance of 3. So we're going to have our numbers have got to be less than or equal to 3 away. That's how we know what to put on that side. Within a distance of 3. So whatever values we choose, they've got to be no more than 3. So we say less than or equal to 3 away. From what? From 2. So in absolute value brackets, we're going to say, hey, when I take my number and I subtract 2 off of it, I don't need to get any more than 3 away. So on the left side, when we solve, we're going to have a positive option. X minus 2 is less than or equal to 3. X must be what?
5.
Less than or equal to 5. That's one option. On the negative side, I'm going to have x minus 2 is what? Greater than or equal to negative 3. Good. So I add my 2 to both sides over here, and I've got x is greater than or equal to negative 1. I think that's what you said earlier, Kimmy. Huh?
How come you have to do all that, but you know it's like 500?
Because you're smart. You know it in your head. We're just writing it down to prove it.
Is it always going to be the equal to?
On these, yes, because it says within a distance of 3. So that's saying that 3 would be allowed.
Okay.
If it could have said fewer than 3, and then it would just be less than. But 3 is allowed here, so we would use or equal to. Good question. There's a try it. Yes or no?
No.
No? No? Done? All right. Tomorrow, you